Hello and welcome. Another video. So today we'll be looking at the process of ionisation. It would be helpful if you have an understanding of alpha, beta and gamma emissions and of the structure of the atom. Now if you're unsure of these things, take a look at the last video I did on the atom and the types of radiation. I'll link it below in the description. Just a wee warning to you in advance, towards the end of the video I'll discuss briefly why ionisation is important to us and the role it has in the development of cancers. That's just a wee heads up because I know it can be an upsetting topic, and honestly the last thing I want to do is upset anyone that's just here to learn a wee bit of physics or get a bit of help with their National 5 physics. Anyway, the outcomes today are: state what's meant by ionisation and state that alpha is the most ionising radiation. As I usually try to do, I'll go into a wee bit more detail than is needed at Nat 5 because some people find the additional detail helps them understand a concept better. But in terms of the Nat 5, all you need to remember are these two outcomes. State what's meant by ionisation, state that the alpha particle is the most ionising radiation. So here's a very basic model of an atom. Mostly atoms have got the same number of protons and electrons. The protons have got a positive charge and the electrons a negative charge, and this is the effect of cancelling the other's charge out. This makes the overall charge of your typical atom neutral. The thing is, the atoms can lose or gain electrons, and when this happens they've either got too few or too many electrons. The atom now has a positive or negative charge, and we say that they become ionised. The process by which this happens is called ionisation. Atoms don't tend to lose protons because they're too tightly bound up in the nucleus of the atom, so it's only the loss or gain of electrons that we'll be discussing today. If an atom gains an electron, it's now got more negative electrons than positive protons, so it becomes negatively charged. If an atom loses an electron, well, now it's got more positive protons than negative electrons, so it becomes positively charged. So on to the ionising power of the three main types of radiation. Another term for this ionising power is the ionisation density caused by each particle. The more ionising power a radiation has, the more atoms and molecules in their path will become ionised. I'll go into a little bit more detail here than's required, but I hope it helps to illustrate the concept of ionisation better, and we won't get too messy in the details. So remember that an alpha particle is made of 2 protons and 2 neutrons. This gives them an overall charge of 2 positive electron charges. Now chemists and physicists just call this a 2 plus or a 2 positive charge. What this means is they're extremely attractive to electrons that are just minding their own business, orbiting another atom. Alpha particles are also the most massive of our 3 types of radiation, which means they've got plenty of energy while they're moving at speed, kinda like a lorry would while travelling at high speed, but obviously at a particle level. So we've got a normal atom here, we've got a nucleus, we've got electrons orbiting round about the outside. When that alpha particle interacts with the atom, the negative electrons are attracted to the positive alpha particle, which can mean they can be stripped away from the atom. The atom's now lost 2 electrons and become positively charged. It's become ionised, it's now an ion. Because of their size and their 2 plus charge, this makes alpha the most ionising of the radiations. They cause the highest ionisation density. In fact, they're called alpha because of this fact. It was a famous nuclear physicist called Ernest Rutherford that named the alpha particle as such because it had the greatest ionising power. So what about beta? Remember, a beta particle is a high energy electron that's released from the nucleus of an atom during beta decay. Well, this high speed electron has a charge of -1. Being negative, it repels other electrons, and at high speed it has the ability to knock electrons out of their orbits. Again, this would create a positive ion. A side note about this, the electron that's ejected from the atom can now go on to ionise other atoms in the vicinity, essentially becoming another beta particle. And finally, gamma. Remember that gamma is a little packet of waves from the EM spectrum. A packet of waves from the EM spectrum, physicists call that a photon. They travel at the speed of light and they carry a lot of energy. Now, gamma can ionise atoms through a number of different ways, but one of these is down to the fact that electrons, when they're orbiting an atom, can absorb the gamma photons, these little packets of gamma. When this happens, the electrons have got too much energy for the atom to hold on to them, and they're ejected. Again, these ejected electrons can become beta particles of their own and cause further ionisation around them. And now for the tricky bit. So when radioactive materials decay, they release these high energy particles or electromagnetic waves, alpha, beta, gamma. This radiation can kill cells. It can have a harmful effect on living cells by causing heating, breaking chemical bonds and ionising the molecules. Now, the most severe damage occurs when the radiation breaks up or ionises the molecules, especially if it happens in the DNA. Alpha and beta particles have much higher energy levels than the energies that keep the bonds of these molecules together. When they come into contact with the matter, they create ions and fragments that are extremely reactive. This can damage the important molecules inside living organisms and disrupt normal cell processes, which puts a strain on the organism's natural repair mechanisms and potentially leads to illness or death. If damaged cells start to divide and replicate, which is a natural process that our bodies use to grow and repair, these damaged cells can replicate uncontrollably and become a tumour. Anyway, now we'll have a look at the past paper examples. So the first one, alpha radiation ionises an atom. Which statement describes what happens to the atom? Have a read out the 5 statements, pause the video and come up with an answer. So remember, when alpha radiation ionises an atom, it strips these electrons away from it, and that means that the atom becomes positively charged because it's lost the negative electrons. So your answer's C. Example 2. During ionisation, an atom becomes a positive ion. Which of the following has been removed from the atom? Again, pause the video, take a wee bit of time to come up with an answer. And so the answer's B, an electron. It's always the electrons that are removed, and when the electrons are removed, there's more positive protons than negative electrons, so that's why atoms become positive. It's the removal of electrons. And on to the final example. A student makes the following statements about ionising radiations. Pause the video, read the 3 statements and decide which answer is correct. So let's go through the 3 statements one by one. First one, ionisation occurs when an atom loses an electron. That's true. Ionisation is when an atom loses or gains an electron, but yeah, loses an electron, that's true. Statement 2, gamma radiation produces greater ionisation density than alpha particles. That's incorrect. Remember that alpha particles are the most ionising. They cause the greater ionisation density than any other form of radiation. And statement 3, an alpha particle consists of 2 protons, 2 neutrons and 2 electrons. Well, that's not true either. An alpha particle is a helium nucleus, which is just the 2 protons and 2 neutrons. So only statement 1 is correct, and the answer must be A. So we'll recap the outcomes. Remember, all you need to do in terms of the exam, state what's meant by ionisation. It's when an atom loses or gains electrons, and state that alpha is the most ionising of the radiations. If you've made it this far, thank you very, very much for your time. Please like and subscribe, and I'll catch you in the next one. Bye.